All right, so picture this. You've spent hours modeling this awesome-looking car, or maybe a cool character in Unity. It's sitting there in your scene, looking perfect, but it's just sitting there. It's totally static. It looks great, but it doesn't do anything. The real magic, the fun, it all happens when you finally bridge that gap between the player and your game, when you hand them the keys and let them take control. Well, that is exactly what we are going to tackle today. We're going to take a static object and breathe life into it with player controls, letting it move, letting it steer, all based on a few simple key presses. Okay, let's dive in.
We're going to break this whole process down into 5 really clear steps, basically taking you from 0 to a fully controllable character. First up, we'll get our heads around the basic idea of bridging the player and the game. Then, we'll poke around in Unity's built-in input manager to see how it works. After that, we're writing code, our very first lines to actually read what the player is doing. From there, it's all about refinement, getting the speed and the feel just right. And finally, we'll put all those pieces together for a super responsive, fun-to-control object.
So, let's kick things off with the most basic question of all. We've got a physical keyboard right here on our desk, and we've got this entire virtual world on the screen. How in the world do we connect those two things?
Really think about it for a second. When you press the D key on your keyboard, how does the game possibly know that you want your character to turn to the right? There has to be something in the middle, right? Some kind of system that's translating your physical action into information that the game's code can actually understand and do something with.
And that something in the middle is called an input system. You can think of it like a translator. Its entire job is to take things like button presses or mouse movements or a joystick being tilted and convert them into data the game can use. Now, it's worth knowing that Unity has actually evolved, and it has 2 of these systems. There's what they literally call the old input system and the new input system. The new one is super powerful for sure, but for this explainer, we're going to stick with the old one, because honestly, it is so straightforward and absolutely perfect for getting your first controls up and running in just a few minutes.
Okay, so where do we find this built-in translator inside of Unity? Well, it's all handled by a really handy pre-built tool called the Input Manager. This is a place where Unity predefines all the common inputs you could ever want to use.
And you can see this for yourself. If you're in the Unity editor right now, just go up to the top menu bar. Go ahead and click on Edit, and in that drop-down, find and select Project Settings. A new window is going to pop up, and on the left-hand side, you'll see a whole list of categories. Find the one called Input Manager and give it a click. Now inside there, you're going to see a list called axes. It might be collapsed, so just click that little arrow next to it to expand the whole list of all the controls Unity has already set up for us. So you'll see this word axis all over the place. What the heck is an axis? Well, the easiest way to think about it is as a named channel for a pair of opposite actions. Think left and right, or up and down. Instead of just being a simple on or off switch, an axis gives us a value, usually a number that floats somewhere between -1 and +1. So if you push one way, you get a negative value. Push the other way, you get a positive value. And if you're not touching anything, you get a nice, clean 0.
And this is where it gets really clever. Let's take a look at the default axis named horizontal. Unity has already gone ahead and mapped the negative button to both the left arrow key and the A key. And the positive button, that's mapped to the right arrow key and the D key. So what does that mean? It means if you press A, the horizontal axis starts reporting a value that smoothly moves towards -1. If you press D, it reports a value moving up towards +1, and if you let go of both, it just returns to 0. This is an absolutely brilliant setup because it means your game works for both arrow key players and Wasabi key players right out of the box with 0 extra effort from you.
Okay, so we know Unity has this input manager thing, and we know it's got an axis conveniently named horizontal. Now it's time for the fun part. Let's jump into a C# script and actually use this information to make something move.
This is really the heart of it, right? We need some way inside our script to constantly be asking the input manager, hey, what's the current value of the horizontal axis? Is the player pressing left? Are they pressing right? Or are they not touching anything at all? We need to be able to ask that question over and over again.
And would you look at that? This single, simple line of code is the key to everything. It's beautiful. Let's just break it down real quick. Input. That's a built-in Unity class that, you guessed it, handles all things related to player input. Keyboard, mouse, controllers, the whole shebang. Then we use a dot to access a function inside of it, called getAccess. This function's only job is to go to the input manager and fetch the current value of whatever access we ask for. And how do we ask? We pass its name inside the parentheses as a string, just a piece of text. Now listen up.
because this tripped me up so many times when I was starting out. That string horizontal has to be spelled perfectly. It is case sensitive. A lowercase h will not work. A pro tip, go back to the input manager, literally double-click the name, copy it, and then paste it directly into your code. You'll save yourself a headache, trust me.
Okay, let's actually put this into practice. We're going to do this inside our script's update method. And remember, update runs once every single frame, which makes it the absolute perfect place to constantly check for player input. So, step 1, declare. We need a temporary parking spot for the input value for this frame. So we'll declare a variable of type float, which just means it's a number that can have decimal points like 1.5 or negative 0.25, and let's call it steer amount. Step 2, assign. Now we use our magic line of code. We say steer amount is equal to the result of input.getAxis horizontal. Now, every single frame, steer amount is going to be updated with a value somewhere between -1 and +1, depending on what the player is pressing. Step 3, use it. Finally, we have to actually do something with this value. We can make our object turn using its transform.rotate method. This method just needs to know how much to rotate on the x, y, and z axes. To make our top-down car steer, we're going to apply our steer amount to the z-axis, which is what controls that clockwise or counterclockwise spin.
So, you save your script, you excitedly jump back into Unity, you hit that big play button, you press the D key to turn right, and your object turns left. You press A to turn left, and it turns right. What? Congratulations! You've just experienced one of the most classic, universal beginner moments in all of game development: inverted controls. Don't even worry about it. We have all been there. The good news is, it's working. It's just backwards.
And honestly, this is a fantastic place to be in. It means our whole system is hooked up correctly. It's just not quite right yet. So now we get to move from just making it work to making it work the way we actually want it to. It's time to refine our control.
So, how do we fix this backward steering? You're probably thinking it's going to be some complex bit of logic, right? Nope. The solution is so simple, it's almost funny. And that's often how it is in coding. We just need to flip the value. If pressing right gives us a +1 but causes a negative rotation, all we need to do is turn that +1 into a -1. And we do that by just putting a minus sign in front of our steer amount variable. That's it. That one character inverts the number. A positive becomes a negative, and a negative becomes a positive. Just like that, our steering is perfectly corrected.
Okay, awesome. Our direction is correct now, but the turning speed is kind of locked directly to that -1 to +1 value. It feels a bit slow, a bit rigid. What if we want the turn to be way faster, like a race car, or maybe much slower and more subtle, like a big truck? We need a way to control the sensitivity of the steering.
So let's build on this. We can get full control over the speed with just a simple multiplication. First, at the very top of our script, outside of any methods, let's declare a new variable. We'll make it public float steer speed equals 100f. Now that little word public is a magic trick. It makes this variable show up directly in the Unity inspector, which means we can change the speed on the fly without ever having to touch our code again. It's amazing. Now, back in Update, we just multiply our negative steer amount by this new steer speed variable. But hold on, there is one more absolutely crucial piece to this puzzle. This is a game dev golden rule. We also need to multiply by time.delta time. What is that? It's just the tiny fraction of a second that has passed since the last frame was drawn. By multiplying by this value, we make our car turn at a consistent speed no matter how fast or slow someone's computer is. Without this, your car would turn insanely fast on a powerful gaming PC and super slow on an old laptop. Time.delta time makes your games feel consistent for every single player. Do not forget it.
We did it! We've successfully implemented and refined our steering control. Now for the final step. Let's put it all together by adding forward and backward movement. And the absolute best part is, we're just going to reuse the exact same logic we just figured out. No need to reinvent the wheel.
See, the pattern is identical, and that's the beauty of good code. First, let's go back to the top of our script and declare another public variable for speed, maybe public float move speed equals 20f. Then, back inside our update method, we create a new float variable called, let's say, move amount. We assign it a value by calling input.getAxis again, but this time we ask for the vertical axis. Unity has already set this one up for the up and down arrow keys, and of course W and S. Finally, we apply this to our object. Instead of rotating, we want to move it, so we use the transform.translate method. We want to move it forward, which is along its local y-axis in a 2D view. And just like before, to make it buttery smooth and frame rate independent, we multiply that move amount by our new move speed variable and by our good friend time.delta time. And just like that, we have smooth, controllable acceleration and deceleration.
And with all that code in place, you hit play one last time. You push W and your object glides forward. You push S, it reverses. You hold D to turn right while you're moving forward, and it works. It just works perfectly. That right there is the aha moment. It all clicks. We're reading two different axes, horizontal and vertical, at the exact same time and applying their values to our object's rotation and position in every single frame. We've done it! We've created a fully controllable character.
So let's just quickly run through that crucial flow one more time. A physical key press gets translated by the input manager's axis into a number. We grab that number in our script using input.getAxis. Then, we multiply it by our own speed variables and the all-important time.delta to get control and consistency. And finally, we apply that result to a transform method like rotate or translate. By understanding this simple loop, you have just unlocked the absolute foundation of player control in Unity. You've given your creation a spark of life. The only question left now is, where will you have it go next?